Hi everyone. So today we will be covering trigonometric ratios and the Pythagorean theorem. So this is a little overview of what we've been learning throughout this week and last week. So today's lesson objective is by the end of the lesson, students will be able to use what they've learned about Pythagorean theorem and trigonometric ratios to break down and solve applied problems. Okay. So here are two different sides of a debate. Okay, so there are two things that we need to know for this lesson. The first one being Pythagorean theorem, and the second one being the trigonometric ratios. We did cover this, like I said, last week or so, but we are going into depth. That way we are able to break down any word problems that we may encounter. Okay, so what is the Pythagorean theorem? This is just a little recall of what we've learned. So the Pythagorean theorem is used on right triangles. That is the first thing that you need to remember. Okay, it is always used on right triangles. Okay, now once we find out that a triangle is a right triangle, there are two things, or one thing that we need to find, and that is your hypotenuse. Okay, your hypotenuse is always the longest side of a right triangle. Okay, that is the most important, because A and B can be arbitrary, they can be switched, but C has to be at the very end, after that equal sign happens, okay, or at the beginning before the equal sign happens. So the equation that we have is c squared is equal to a squared plus b squared, saying that the two sides squared is going to equal your longest side squared. Okay, and again, this can only be used on right triangles. Okay, and this is when we are looking for sides. Now the next one we will talk about is the trigonometric ratios. Okay, so what are trigonometric ratios? What are they used for? So trigonometric ratios are used to find missing angles, missing sides, depending on how much information we have. Okay, so let's talk about SOHCAHTOA. If we remember, okay, SOHCAHTOA is an acronym for trigonometric ratios, where the SO stands for sine, and in order to find theta, meaning our angle, we will have to use the opposite side over the hypotenuse, and we have to do some solving. Excuse me. Now the next one we have is the part, okay, and that is for the cosine, and cosine works with adjacent and hypotenuse. And then the last one we have TOA, which is tangent of theta, which is your opposite over your adjacent. Okay, so what does all this mean? What is your opposite? What is your hypotenuse? Okay, so if we are looking for sine of theta, okay, for example, this here is your theta. In order to find your opposite over hypotenuse, again, what is opposite of your theta is just straight across. This line here is the opposite of your theta. Okay, and then again, your hypotenuse is always your longest side. In this case, this here is your longest side. Oh, sorry. This here is your longest side, and that's your hypotenuse, always across from that 90-degree angle. Okay, the same thing for cosine, tangent, and all other trigonometric ratios that we've learned. Okay. Okay, so example number 1, let's go ahead and get started. The first thing I want to make sure that you guys know is that you need to remember that when we are working with word problems, the easiest thing to do is to break it down. Okay, so whatever we are reading, we are going to write down. Okay, so this here is your right triangle. Okay, so let me read it to you. A 13-foot ladder is placed 5 feet away from a wall. The distance from the ground straight up to the top of the wall is 13 feet. Will the ladder reach the top of the wall? Okay, so I know that my ladder is 5 feet away from the wall. Okay, so that part there. Okay, I'm gonna go ahead and erase that because I just drew all over it. So 5 feet away from the wall. So that's where my 5 feet goes. Again, this is your wall. We also know that the ladder that is leaning against the wall is 13 feet. It's a 13 feet ladder, okay? So your hypotenuse in this case, again, across from your 90 degrees is 13 feet, okay? So now when I go in and I plug it into my equation, a squared plus b squared equals c squared, I need to find my c, which is the most important. Again, c always happens across that right angle, okay? Again, your wall and the number 5 can either be A or B. They can be switched. So in this case, I'm going to say that A stays the same. Okay, that's your wall height. Plus your B, I am going to say that it is 5 squared, which is equal to, again, C is always across your right angle, which is 13 squared. Okay, now all I'm going to do is I'm going to go ahead and solve. So I have A squared plus, what's 5 squared? Is 25, which is equal to 13 squared is 169. Okay, now I want a squared by itself, so I am going to subtract 25 to both sides. Then I'm going to do it right up here. So I have a squared is equal to 144. In order to get rid of that square root sign, I have to take the square root. Okay, that square root cancels that squared. So I have A is equal to 12. So now I know that my wall height is 12 feet. Okay, so now it's asking me, will the ladder reach the top of the wall? Okay, it will not reach the top of the wall. So no, the ladder will not reach. The reason being is because that 12 centimeters, no, the ladder will not reach. Again, the reason being is because 13 is bigger than 12 and 12 is the side of your wall, so therefore it will not reach. The ladder is bigger than that wall. Okay, so again, my recommendation to you is to try it out, pause the video when needed. If you get confused, make sure to write them down so you can ask me any questions you may have. Now, your turn number 1. This is for you guys to complete. I will go over it, but before I do, I want to make sure you pause me here. After you complete the your turn number 1 problem, I would suggest for you to play my video so that I can show you what I did. Okay, so I'm going to go ahead and get started. John leaves school to go home. He walks 6 blocks north and then 8 blocks west. How far is John from school? Okay, so the first thing I need to do, and I provided that compass for you so that you can see where your north, east, west, and south are. Okay, so I'm going to go ahead and start. So John leaves school. Okay, so this is his school. He walks 6 blocks north. Let me start a little bit further down. So again, he starts at school and he's going to walk 6 blocks north. Okay, so he goes up a couple blocks. Okay, sorry about that. So that's your school starting. He walks 6 blocks north and then 8 blocks west. Okay, so 8 blocks west, he's going to the other side. Let me go ahead and restart that. Again, sorry for that. So I'm starting south and I am going 6 blocks north, and then he will start 8 blocks to the west. Okay, and how far is John from school? Okay, so again, this here will be his home. Okay, and how far is he? He wants to find this distance here. Okay, so I just created my right triangle. So now all I have to do is use Pythagorean theorem to find how far John traveled. Okay, so again, I do not have a C because this here is my right triangle. So I do not have a C, but what I do have is A and B. Okay, so I use Pythagorean theorem, which says A squared plus B squared is equal to C squared. I'm going to go ahead and solve that. So 8 squared is 64 plus 36, which is equal to C squared. Sorry. Okay, so after this, 64 plus 36 is 100, which is equal to C squared. In order to solve for C, I need to get rid of that squared. So now I know that C is equal to 10. So how far is John from school? John is actually 10 blocks from school. Okay, if he were to travel just from school to his home, he is 10 blocks from home. Okay, so thank you for that video. If you guys have any questions during the video or before the video or after the video, please feel free to ask me during class. It was fun helping you guys with word problems and the Pythagorean theorem. Again, make sure to ask those questions because I will be asking a couple of you what you got from this video. Thank you. I hope you guys enjoyed.